Welcome to The Explainer. I am absolutely thrilled you're joining us today because we are setting the stage for a massive time-traveling journey. We're going to track the entire evolution of robotics invention, literally everything from the earliest concepts dreamt up way before electricity was even a thing, all the way to the incredibly advanced autonomous machines we're seeing today. So get ready, because the story of how human imagination eventually caught up with technological reality it's a truly mind-blowing one.
So if I were to ask you right now, just off the top of your head, when was the first robot invented? What would you say? I bet most people would immediately picture a black and white photo from a mid-20th century factory floor, or, maybe some blocky 1980s sci-fi movie prop. But what if I told you the real answer to this question actually predates the modern era by thousands of years? Okay, let's dive into this. Take a look at this quote. This is Aristotle, the legendary ancient Greek philosopher, writing all the way back in 322 BC. He's literally dreaming of a world where instruments could do their own work at the word of command. He specifically references the mythological self-moving tripods built by the Greek god of metallurgy, Hephaestus. That's right. Ancient Greek philosophers were conceptualizing autonomous machines and the end of manual human labor over 2 millennia ago. The whole idea of the robot has been sitting there in human consciousness for a very, very long time.
To map out this journey, here's our quick agenda. First, myths and early automata. Second, the first industrial robots. Third, reaching space and surgery. Fourth, giving robots senses. And finally, 5, the humanoid era.
All right, let's jump straight into Section 1, Myths and Early Automata. Before we go any further, we kind of need to define what a robot fundamentally is in a historical context. Back then, the word they used was automaton. It comes from the Greek word meaning acting of one's own will, and it was actually first chronicled by Homer in the Iliad. In the ancient world, an automaton was essentially dead material miraculously brought to life at the command of its creator.
Let's look at the timeline here and see how this drive to build automata led to some stunning early inventions across a massive gap in time. Way back in the 4th century BC, a mathematician named Archytas designed a steam-propelled mechanical bird known as the pigeon. Fast forward to 150 BC, and the ancient Greeks built the Antikythera mechanism, which was basically a sophisticated analog computer designed to calculate astronomical positions. Then, skipping ahead quite a bit to the 18th century, we see the creation of Wolfgang von Kempelen's mechanical Turk in 1770. You can see inventors slowly moving from steam-powered novelties into really complex calculating mechanisms.
Now, what's really interesting about this slide is the story of the mechanical Turk itself. It was originally built to impress the Empress of Austria, and it looked like this large wooden cabinet with a life-size mechanical man dressed in robes sitting behind it. It went all around Europe and America, defeating brilliant minds like Benjamin Franklin and Napoleon Bonaparte at chess. No way, right? Well, yeah, it was actually a brilliant hoax. Inside that cabinet, filled with brass gears and clockwork parts, a human chess master was hidden, secretly operating the machine. It just perfectly captures how desperately we wanted machines to think, long before they actually had the capacity to do so.
Moving right along to Section 2, the first industrial robots.
So, where did these machines go once the technology finally became real? They went straight to the 1950s factory floor. What you're seeing here is history in the making. The Unimat, designed by George Devol and Joseph Engelberger. Installed at a General Motors plant back in 1959, this is widely considered the very first true industrial robot. It didn't look anything like a human. It was basically a massive single arm, but it was fully capable of performing real heavy-duty labor. Just to emphasize the sheer scale of this thing, the Unimate weighed a staggering 4,000 pounds. To put that into perspective, that's roughly the weight of a mid-sized car. This 2-ton Pioneer was controlled by a program stored on a very rudimentary magnetic drum. Its main job was to sequence and stack scalding hot pieces of die-cast metal, a super dangerous, repetitive task for humans. And it did this with an accuracy of 1/10,000th of an inch. This massive piece of machinery completely revolutionized the automotive industry and proved, for sure, that robots could be highly productive tools.
Section 3, Reaching Space and Surgery.
Once robots had firmly conquered the assembly line, humanity realized their potential was virtually limitless. So we started deploying them into extreme, high-stakes environments, like deep inside the human body. Surgical robotics evolved incredibly fast. In 1985, a repurposed industrial arm called the Puma 560 was used to place a needle for a brain biopsy. Why? Because a machine doesn't have a hand tremor.
By 1994, we had ASOP, an FDA-cleared arm specifically for holding laparoscopes. In 1998, the Zeus system literally allowed a doctor sitting in New York to operate on a patient all the way in France. And by 2000, the famous Da Vinci system hit the market, giving surgeons high-definition 3D vision and miniaturized instruments. To date, Da Vinci systems have completed over 10 million procedures worldwide. 10 million!
And this brilliantly illustrates the other major extreme environment, deep space. This quick breakdown maps out a quarter-century of continuous robotic exploration on Mars. It all kicked off in 1997 with the tiny 23-pound Sojourner rover. Then came Spirit and Opportunity in 2004, which vastly outlasted their expected 90-day lifespans. Opportunity lasted over 14 Earth years. Then in 2021, we landed Perseverance, which is up there right now collecting rock samples, alongside the Ingenuity helicopter, which marked the absolute first powered flight in the Martian atmosphere. These robots act as our avatars, surviving and exploring where humans simply cannot go yet.
Which brings us to Section 4, giving robots senses.
Doing a predictable, repetitive task in a controlled factory, or even rolling slowly across an empty Martian desert, is very different from navigating the unpredictable, chaotic human world. To finally step out of those controlled environments, robots needed a massive technological leap. If we contrast early sensors with modern perception, the difference is night and day. Early sensors were largely blind and rudimentary. We're talking simple physical bumpers to stop collisions, basic limit switches, and photocells. Today, robots possess this incredibly rich sensory tapestry. They use LiDAR for precise, real-time 3D mapping, sonar, and high-definition vision systems to actually see their surroundings.
But here's the catch. All those expensive cameras and LiDAR sensors, they're completely useless without a way to process the information. That is exactly where artificial intelligence and deep learning come in. AI acts as the robot's brain. By training on vast, massive datasets, AI finally allows robots to recognize patterns, classify objects, and navigate dynamically on the fly. It takes that raw, chaotic sensory data and transforms it into intelligent, autonomous decisions.
And that builds up perfectly to Section 5, the climax of our explainer, the humanoid era. With the combination of advanced mechanics, rich sensors, and powerful AI brains, we have finally arrived at the era of machines built in our own image. Modern humanoid capabilities are just mind-blowing. Think about robots like Honda's Asimo or Boston Dynamics' Atlas. They have this mechanical athleticism that allows them to jump, run, and literally do backflips with incredible robustness. Thanks to natural language processing, they can communicate intuitively with us using regular speech. And most importantly, they are becoming enterprise-ready. Boston Dynamics, for example, is rolling out a fully electric, production-ready Atlas by 2026 that is designed to work autonomously and safely right alongside humans in factories and logistics centers. So, the crucial point is, this isn't just a fun technological marvel. It's a massive societal shift we are actively navigating. As these robots enter the real-world workforce, it brings up some very real practical and ethical questions. How exactly is this going to shift human labor? How do we handle privacy and security when you have highly autonomous, sensor-rich machines walking around our workspaces? And on an even deeper level, what does human-robot interaction look like as everyday people begin forming actual emotional connections with these lifelike machines?
We started today by looking at ancient Greeks dreaming of autonomous tripods, and now we're standing right on the brink of living alongside fully autonomous humanoids. So as we continue to build machines in our own image, what really is the future of human-robot coexistence? It's a fascinating, complex question that we are all going to have to answer together in the very near future. Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll see you next time.